What I want to show you isn't so much tied to weather forecast or anything like that, because I'm not a climatologist. I'll tell you that right up front, and I'm not a weatherman. But I do want to show you some numbers that you can relate back to your operation going into the future, moving forward. This picture was taken on 3/15. Things still weren't real good for native grass producers. And you know, we had good moisture, but things just hadn't really busted off. Now, if you were, you know, had Bermuda grass, were down in the lowlands, had good bottomland, you were already at this stage growing good ryegrass and wheat and so forth. But there's three issues I'm going to focus on today. One of these is stocking rate, and we hear that all the time, but after last year, I think it might be even more important to your operation looking forward, and I want to give you some things to think about. The other is ground cover. Things that I'm noticing right now is areas where the ground stayed covered last year, even though it was dormant and dead, and even though you thought it was overgrazed. If your ground was covered with some kind of litter and it wasn't just bare soil, you're going to be okay. You're going to have plant growth this year. We've got good soil moisture, and they may be a little slower coming out, may not be quite as productive early on, but I think here in the next 30 to 45 days, you're going to catch up and you're going to see a pretty good year. If your ground was slicked off and there was a lot of bare soil exposed and it heated up and your plants were shallow rooted, we may have to take a little more time to get things to cover. And then the other issue I'm going to talk about is rest. Happy Easter last weekend. I went to sunrise service. We left sunrise service and drove to Turner Falls, and it looks like a poor quality picture on the left, but actually it was kind of fog or steam that was rising. Turner Falls was just gushing. It looked beautiful. We hadn't seen it do that in quite a while. After church, we drove and looked at the headwaters of Honey Creek, and it was just bank to bank. We couldn't cross that. In fact, we had a lease hunter that had tried to cross that in his ATV. It turned it over. Had to get a winch truck in there and pull it out. We're lucky we didn't lose the hunter, I guess. Went back about 3 days later and looked at a tributary to Honey Creek, and God, the water flow was just still tremendous. I've never seen so much water in the Arbuckles as I did this past week. And what was really neat to me, the water had cleared. In that previous picture, it was pretty muddy. That was the day it rained, but after a couple of days, the water was flowing extremely clear. So things change in a hurry, don't they? What you looked at was a weather event right there. The rainfall we got. What's happening today? That's weather. Climate is the long-term average of all these weather events. So very seldom do we actually talk much about climate. Climate refers to the zone of the country, the area of the country that we live in. Our climate, for example, is temperate as opposed to tropical. We have hot summers, cold winters, a bimodal rainfall pattern, and the grasses that we produce tend to be warm season perennials because of the climate that we have. The other two factors that go into producing the grasses that we have in any given region are soils or parent material from which the soils come from, and then topography, the elevation that you're at, the slope of a hill, exposure of the plants along those slopes. Two books, I used to put suggested reading up here, but I think now I want to call these required readings. A couple of books that I think everybody ought to go back and read just so you understand what's happened in the past. Because what I'm going to show you today is what's happened in the past and then relate that to the future as to what could possibly be going on. But one of these is The Worst Hard Times, and it's about the Dust Bowl days. About the people, not like the Grapes of Wrath, that left and went to California, but it's about the people that stayed in the high plains and endured the 30s. The other book is A Time It Never Rained, and its setting is more in sheep and goat country, kind of in the San Angelo area, and it talks about the drought of the 50s and what those people endured. And it's just some great historical fiction that anybody that's involved with land management, with cattle, livestock, I think should take a look at. April 12th, 2011, that's a year ago almost today. Things were getting pretty severe. You know, we kept thinking, well, May's coming, it's going to rain, it's going to rain, it's going to rain. but they were predicting that it may get worse, and in fact it did. But that's what we looked like last year about this time. This year, you can see southern Oklahoma, north central Texas, much improved. Last year, this year, last year, this year. You can see, though, the western part of Texas, far southwestern Oklahoma, New Mexico is still suffering from drought. They still need rain. The other thing that worries me is last year again, this year, is the southeastern part of the U.S., you know, Florida there, Georgia, a little bit of South Carolina, the far southwestern U.S., and the north central part of the High Plains. You know, it's dry in those parts of the country right now. The High Plains up there in the Dakotas, in Illinois, can recover quite rapidly because their soils are very deep. So they've got moisture there from last year. They just need the rain, which they have not had, but they need the rain right now to go ahead and bring that moisture back to the surface. North America, you know, anymore we're pretty global in the way we think. Our commodities are global, even our cattle. We get a lot of cattle out of Mexico, but if you look, you can see that Chihuahua region, even over in the peninsula of Baja, you know, that country's pretty dry as well. So they're suffering right now like we did last year, and this is their second year of drought. So, you know, look around the country and see where the drought is existing. It's where it's existing or progressing. Our outlook for us is pretty good according to the seasonal drought outlook. Aljo mentioned that La Nina was gone. It in fact is pretty much gone. If it's not, it probably will be by the end of this month. But as far as El Nino coming back, that's a question mark right now. Most of the climatologists give El Nino about a 60% chance of coming back, which would give us a 40% chance of staying neutral or slipping back into another La Nina event. And I'm going to talk to you a little bit about La Nina and El Nino here in just a second. Some of you have pens. I would ask that you write these three things down, take them home with you. The three most important issues about range management, the first of these is stocking rate. Even in a wet year right now, stocking rates are important. In fact, I think stocking rates are probably more important in a wet year than a dry year. And the reason being, we use the term overgrazing a little bit loosely. Overgrazing is repeated grazing of a plant to the point where we abuse that plant and weaken it. Well, if you think about plants, then theoretically, the only time we can overgraze a plant is when a plant's growing. If a plant's not growing, we typically do not think in terms of overgrazing it. Yeah, we may remove more material than we should and expose the soil, or we may cause it to not be able to come back quite as well in the spring. But the most harmful overgrazing occurs when plants are growing. And think about last summer. How many of you had growing plants in July? None of us did. So theoretically, we weren't overgrazing in July in terms of the way a plant's thinking. It would have been like running a fire across there and removing all the vegetation. And, you know, we may have had other problems. We may have had soil erosion. The soil could have heated up. But I think of overgrazing in terms of when plants are growing. The second most important thing with regard to range management is going to be stocking rate, even in a normal year. And then finally, the third most important thing that you need to consider in your operation is stocking rate. 117 years of rainfall data. Let's look back in history. The thing that stands out to me, and this is for the state of Oklahoma, you don't need to be able to see all the numbers, but 34 inches is average for the state of Oklahoma. That's normal rainfall in a year. This is going back from 1895, and it goes all the way to 2011. But the thing that strikes me as curious here is that you'll get, 10 or 15 years of dry, 10 years of wet, 10 years dry, 10 years wet, 10 years dry, 7 years wet, 11 years dry, 7 years wet, 10 years dry. 30 years wet. So what these little black diamonds mean, that's the total rainfall in any given year for the state of Oklahoma. Here's our long-term average, and then this trending line is a 5-year rolling average that tries to depict for us, you know, wet cycles and dry cycles. It takes some of the noise out. A little bit about El Nino and La Nina. This is an oscillator. El Nino, a lot of you see ENSO, you know, it sounds real technical, ENSO. It's El Nino Southern Oscillator. El Nino meaning little boy. And when we are truly in an El Nino, what is happening is that the water temperatures rise in the Pacific, and we get a very strong Pacific jet stream as opposed to a polar jet stream, but we get a very strong Pacific jet stream. And you've all seen those rains that develop in California, and if the winds are from the west, you know, in about 3 or 4 days, you have a pretty good idea that you're gonna get some of that rain. Well, what happens in a La Nina event is that the water actually cools, and there's so much water in the Pacific that actually cools the air temperature. Cool air can hold less moisture than warm air, so we A, have less moisture in the air, and B, this Pacific jet stream tends to be pulled up north, and so the Pacific Northwest is the area of the country that gets most of the rain. Like last year, Pacific Northwest, you know, Washington, Montana, the Dakota, they flooded, you know, and we were in severe drought. So last year was a classic La Nina. The other oscillator, and this one kind of worries me. I listened to Evelyn Browning a couple of weeks ago, and she truly is a historical climatologist, Evelyn Browning Garris with the Browning newsletter, but I got to visit with her last week at TSCRA. And she puts a lot of credence in what's known as the Pacific Decadal Oscillator. Decadal meaning decades. This is a 20 to 30 year signal for wet periods and dry periods in the southwestern portion of the U.S. And this is basically the same as the El Nino Southern Oscillator, but it's looking at it over a long period of time. And she believes, as do many other climatologists, that this oscillator tipped right here in 2007. And she thinks that it is cooling, or at least the numbers show that it is cooling at this point in time. Well, I thought, wouldn't it be interesting if we took that and looked at that in terms of rainfall across the state of Oklahoma and looked at when it tipped. If we look here in the mid to late 40s, it tipped and it got cooler. What happened in the late 40s and the 50s? And this even goes on into the 60s. Cool, you know, a negative reading on the oscillator. We kind of had drought. Here in the late 70s, it tipped again, but it did so warming the waters, and we moved into a long 30-year period of wetter than normal. And most of the scientists agree that it has tipped about 2007. Some of them thought it tipped right here, but it gave us a little false reading and came back up over the line, and now it's tipped back down. And they think that the temperatures of the waters are cooling and will do so for the next 10, 20, 25 years. So what does that mean? I don't know how much faith I put in this, but historically we have seen some tremendously long dry times. I'm just telling you, not that it's going to be that way, but to think, what if it is? Probability looking back. Let's look at that 117 years again and see what it's been like in the state of Oklahoma. I counted all these little dots, and this is 34 inches again, going to 5 inches greater than normal, 5 inches less than normal. 29 out of 100 years, we are a little bit drier than normal, and 28 out of 100 years, we're from 0 to 5 inches wetter than normal. 5 to 10 inches wetter than normal occurs 16% of the time. 5 to 10 inches drier than normal occurs 13% of the time in the state of Oklahoma. And then 6-7% of the time we're 10 to 15 inches in terms of yearly rainfall, either drier or wetter than normal. So, 6 or 7 years out of 100 years, I would expect to receive 15 inches, from 10 to 15 inches less than normal rainfall. What's my point? The point is drought is normal. Wet years are normal. Expect that they happen. We never have a normal year. Only, Deke came in my office and we were looking at this, and we only found a couple of years that we could have called normal out of the last 117 years. And this doesn't even tell the whole story, does it? Oh yeah, I forgot this. You can take this one to the bank. 50% of the time we're wetter than normal, and 50% of the time we're drier than normal. Okay, let me give you a take-home question. Is your stocking rate proper? What is proper stocking rate? How can we stock properly with that kind of variability, right? Given an old range management principle that we can stock at a rate of 1 cow per section per inch of rainfall, if Oklahoma is in a 34-inch rainfall zone, then I can run 34 cows per section. Or another way to look at that is take that section, divide it by the inch of rainfall, and I end up with a stocking rate or a carrying capacity of 19 acres per cow. Well, 34 inches again. Look at the variability. It changes all the time. There's a factor going on here that I call the new normal. I took the last 30 years, not including 2011, but I went back 30 years and took an average of the last 30 years to see what normal rainfall was just in that small time period, and come to find out normal for the last 30 years is 37 inches, not 34 inches. And that's what most of us have in our minds in terms of stocking rates at this point in time. The new normal. I'm 50 years old. I didn't start thinking about stocking rates till, well, I was really a little older than 20 probably. I was probably thinking of other things at age 20, but I've had 30 years of experience in this business, and this is what I've had to work with right here, that red bar. Times were good. We didn't know what drought was. We always talked about them here, but we really didn't know what they were. So I took that same equation and I broke it down. Well, what if we're slightly wetter than normal? Well, instead of 19 acres per cow, I can run at a rate of 17.5 acres per cow. 5 to 10 inches greater than normal, about 15 acres, and 10 to 15 greater than normal, 13 acres per cow. But look down here on the bottom side. Instead of 19 acres per cow, if I am extremely dry, and lived in this kind of a rainfall zone down here around 22 inches, my stocking rate would be 30 acres per cow. So we have a variability just in the state of Oklahoma based on different years of almost 16 acres per cow. So when you call me and say, Chuck, what is my stocking rate? What should it be? It's very difficult. My brain starts short-circuiting, and there's lots of other things that go along with it. And here we're only looking at total rainfall, right? There's something else that we need to consider, and that is how much of that rainfall is effective. If I get a 15-inch rain in January, how much grass does that grow in July? In most years, not a whole lot for us because our soils aren't real deep. If you're up in corn country, it makes a huge difference. But here where we've only got a couple of inches of topsoil and then we get to some clayey subsoils, we don't store a whole lot of water in our soils. So oftentimes some of the old timers will tell you it doesn't matter how much it rains in January, that doesn't grow grass in July. And that's true for some people. The rains that we get need to fall in March through June if we're going to grow warm season perennial grass from mid-April to July. In fact, 75% of your total production typically occurs by the 4th of July, okay? So start watching, and I know you are. How many of you are writing down rainfall and keeping accurate records now on your calendars and used to never do that? Well, there's one or two that are. I think the rest of you are just afraid to raise your hands. You might jinx the rain that we've been getting. Keeping the ground covered, very important. Here's an area that was overgrazed. This is last year in August of 2011. grass is real short. Maybe it wasn't overgrazed from the standpoint of grazing like I was talking about, but it is overgrazed from the standpoint of the soil's beginning to become exposed. And if you look at this little bluestem plant right next to it, there are not any green leaves in this plant, and we got 1.5 inches of rain, 1.5 inches of rain in August, and I took this photo about 5 days later. Right next door, I mean not 10 yards away where the grass was good, a lot of green appeared. This was, you know, I thought this was fantastic. Now, it didn't grow a lot of extra grass to graze, but just looking at that response difference told me that where my plant condition is not real healthy, I'm not storing a lot of water. My regrowth potential isn't what it should be, but where my plants are healthy, I can do a lot more with a lot less. Hugh Aljo's come up with a neat system. I'm not going to show you exactly what he's doing, but he starts monitoring rainfall in that October time frame in terms of estimating forage production for the following spring, and it's pretty neat. He tracks how much rainfall and what % of normal we receive from October up through April, and he keeps track of that to see if we're ahead or behind schedule. And yesterday he was showing me that we're at about 10% ahead of schedule for this region of the state. This is southern Oklahoma, and rain was fantastic in October, November, December. The previous year we were dry and continued to be dry in the months that it was important, but this year's been fantastic. Moving into January, February, the blue line's depicting how much actual rain we received. The red bar is average for the month. So we were way ahead in January, a little behind in February. Again, this is the entire region of southern, south central Oklahoma. April, I just plugged in what number I knew that we had. We'd gotten about 3 inches last weekend. Yesterday, I heard somebody told me they had 5 inches up around Chickasha. Isn't that fantastic? And so we're in good shape. We're in good shape this year. March 5th, I took a picture of some native grass country. Looks fairly overgrazed. You don't see a lot of green warm season grass coming. I am seeing a light green hue of cool season annuals and forbs that are going to be coming up. On the 24th, I went to the same place to take another picture, and I came back home, and you know, I felt almost like Dr. Frankenstein when he created his monster, but I was yelling, "Hey, it's alive, everybody, it's alive!" And they were going, "What's alive? What are you talking about?" And I said, "Our grass." You know, I looked at these little blue stem plants and could see some green coming up, and sure enough, folks, this is only March 24th. I don't think I have ever seen warm season perennials kick off this early. But I was seeing 2 or 3 leaves and a bunch of tillers in these clumps. And then last weekend, I went out again. It's not even mid-April, April 8th. And this green you're seeing is little blue stem. This wasn't cool season annuals. This is little blue stem. It's already 6, 7, 8 inches tall. Now, it's not real thick, but the leaves are there. It's coming back. So I got very excited when I looked at this. But the thing that I want to stress to you is it's time for many of you with native grasses to start keying on management of these warm season perennials and forget about what's happened with the cool seasons. I mean, you're not going to be able to graze all those cool season annuals at this point in time. Those of you with Bermuda grass, it's time to think about getting those cool season annuals off. I know it's a little bit early, but if you want to try to let your Bermuda recover this summer, we need to try to get those cool season annuals off. Something else in terms of plants that are very important is active rest. Active rest meaning resting when a plant is growing. Rest when a plant is dormant. To say, well, I rested them all last winter, that really doesn't do a whole lot. A plant has to be growing to rest. It has to be growing to rebuild its reserves. So if you've got a native grass pasture that's been abused, maybe full season rest is what you would need on that pasture this summer. If you're in pretty good condition with your pastures, then let's look at half season rest. Put your cows together, graze half of it during the first part of the growing season, then move the cows and graze the other half during the second part of the growing season. In this situation, this is what it could look like by mid-June. This photo was taken in '09, but that's a little blue stem. It's abundant, doesn't look like it's been grazed, and in fact that year it had not. This pasture was rested up until about the 4th of July, and that's the quantity of forage that was out there. Already had 3,000, 3,500 pounds of dry matter produced by that period of time. Not rested and continuously grazed. Here's a heifer pasture that is not managed very well. However, it was rested the entire second half of the season, and the forages that came back in that were tremendous. So, you know, you can't always judge something by looking at it one day. You have to look at it seasonally over time and try to see what direction you're trending. Something that you guys have available to you now, and we have for a couple of years, is drought insurance. You can insure your forages against lack of moisture through using pasture range and forage rainfall index insurance. And this insurance comes from the USDA. It's part of their risk management agency. And a lot of people in Texas and Oklahoma have begun using this. It allows ranchers and farmers to insure a percentage of their average rainfall in selected 2-month intervals throughout the year, and it's subsidized with your tax dollars by up to 59% of the premium. It's the same guys that write the corn insurance up in the Midwest and all your crop insurances. We're just not used to this and haven't seen it, but the paybacks on it look to me like they would be worth it. So in conclusion, we're going to wrap up, and I'm going to tell you that you need to estimate your stocking rates based on long-term averages, not short-term averages. Short-term being 30 years, long-term being 100 years. You need to work to keep the ground covered at all times. That's one of the most important range management principles behind stocking rates. And you need to look to make active rest, make plant rest, a part of any grazing program. A couple other things: monitor rainfall and inventory your resources. It's neat. If you get used to taking your iPhone out and seasonally taking pictures in the same area, it's neat watching them progress, and it's easy to do now. Used to, none of us would take a camera, but people will do that with their iPhones, and you can even post them on Facebook, and we'll go look at them with you or something. Consider using risk management, and you know, always thinking to the future. What if it is wet? What if it is dry? What am I going to do with too much forage or too little forage? And with that, I'm going to leave you with a sunrise, not a sunset, because times are definitely better right now than they were a year ago. Aljo says we've got time for a couple of questions if there's anything on anyone's mind. Yes, sir. The question is, there's a tremendous explosion in Red River County, in many counties across this southern Oklahoma and North Texas, of ryegrass, cool season annuals, and clovers. Will that affect or hurt our Bermuda grass or warm season perennials coming behind it? And the answer to that is yes and no. It's going to depend on, do we continue to get rainfall throughout this summer? If these cool seasons and this clover use all the moisture over the next 30 days and deplete our soils of moisture and we don't get rain, it will be detrimental to the warm seasons. If we can graze them, hay them, get them off somehow, and continue to get rain, the effect will be minimized at that point. But yes, it is directly competing right now with our warm season perennials. And normally it doesn't this time of the year, but we're a good 30 days ahead of schedule in my mind. I don't know what the rest of you are seeing where you live, but anything else? Yes, sir.
In your analysis, anywhere do you account for the average temperature or whether or not that's changing?
You know, I have not looked at it. He's asking if we account for the average temperature and whether or not that is changing. I guess we can say yes, we do, by watching the oscillators in the Pacific there, but in terms of a global warming scale, we do not at the Noble Foundation. There are plenty of people out there that will give you some very sound opinions about that. In my mind, I've studied ecology, and going way back to the Pleistocene ages and the ice ages and so forth. I do know that climate changes and has changed. There's evidence of glacial till all the way down to Kansas, and when those glaciers move down, we get wetter, and when they retract, we get drier. But it's hard in anybody's lifetime to be able to pinpoint the trend as to whether we're getting warmer or cooler, but it is happening. I do think we're going one way or the other, but which way that is, I don't know. We're talking tens of thousands of year cycles, not 8-month cycles or even 20-year cycles. One more question. Yes, sir. Will El Nino effects moderate temperatures as well? If you get the rainfall, yes, because rainfall tends to buffer temperature. And so like last year when it was dry and hot, the longer it stays dry and hot, the drier and hotter it becomes. Drought begets drought, and rain begets rain. So moisture buffers temperatures, so in El Nino overall, it should help to buffer those extreme hot temperatures like 115. But there's a lot of these climatologists that do feel we're going to have a hot summer. Sometimes I don't know what's best, 115 and dry or 100 degrees in 90% humidity. So as far as you feeling hot, yes, and I would still contend that if we have more moisture, it would moderate those temperatures a little bit more. And he's asking about the extreme temperatures in the soil and so forth. A lot of these plants have lived through this in the past. I mean, they've been genetically selected for to live in the Southwest, and that's why we see warm season perennials in our part of the country. But again, with what we just talked about, the most important thing in terms of protecting your plants during drought is what? Keeping the ground covered. Vegetation, organic matter on top of the soil, a thatch, your soils won't heat up nearly as much as they will if they're bare. We had bare soils hitting 120, 30 degrees, whereas soils that were covered probably never got over 110 or 15. So, all right, thank you.